Okay, so here we are in section 6.3. This is all about logarithms. So let me write that for you. Logarithms. Okay. Now I realize you probably don't really know exactly what a logarithm is. It probably seems like a weird and strange word and what it does, but it's actually not that hard. Let me show you. Basically, a logarithm, it is the inverse of an exponential. So a logarithm is the inverse function of an exponential. So let me give you an example. Suppose you have something like 2 to the third power equals, now what is 2 to the third power? It means 2 times 2, which is 4, times 2, which is 8, right? 2 to the third power is 8. Well, basically, if I bring in the word log, you see how this 2 right here is the base? And what does base mean? When we say that 2 is the base, we mean 2 is the bottom part, right? Like the base of a table is the bottom part of the table, right? The base of something is the bottom part of it. So when we say 2 is the base, for the logarithm, they have a number that goes down. It's also the base. But it kind of goes low down at the bottom of the G like that. And we call that the base of the logarithm. The main point I'm making is the base of the exponential is the same thing as the base of the logarithm. And then these other two switch positions. The 8 goes here and the 3 goes there. So there's the rule. Let me write out that rule. Here's the rule. To change forms between log and exponential, what you do is the base stays the base. Did you notice the base didn't change? 2, 2. And base just means the bottom part, the low down part. The base stays the base. The other two switch because they invert, because it's an inverse function. Remember how inverse functions, we always switch x and y? Well, logarithms and exponentials are inverse functions. So if you have something that's a exponential, and then you change it to a log, all you do is the base stays the base, and then the other two switch. And you're saying the same thing in two different languages. We know this language, right? 2 to the third power equals 8. That language we speak. That's the power language, the exponent language. But this language is kind of weird. Log, how you say it is log base 2 of 8 is 3. That's not a language we speak naturally, but it's saying the same thing that the other one said. It's just saying it in a different language. Kind of like if I say 1 or I say uno, right? 1 and uno, that's the same number in two different languages, isn't it? Well, that's what this and this are. They're saying the same truth. 2 to the third power is 8. In the exponent language, and then down here in the log language, log base 2 of 8 is 3. That's saying the same thing in two different languages. And how we change between those languages, to change between the languages, the base stays the base, and the other two switch. That's all you got to do. So let's try it here. They're giving me a log statement. See how that R is down there is the base. It's down low at the bottom of the G. Log base R of Z equals B. So now I want to say the same thing in exponential form. Okay, so how's that? Well, the base is going to still be the base. It's going to be the low down part that has something on it. And then the other two will switch, because inverse functions, and that's what logs and exponentials are, inverse functions have a switch. So the b will go up there where the z was. See how it looked like r to the z, but now it's r to the b, and the z goes over there. That's what they're saying is the answer. There we go. This is saying the same thing in exponent language as this was saying in log language. That's all we got to do to change between exponents and logs. Let's try the next one. So they're saying, here's a log. Oh yeah, now this one, notice, doesn't have a base. In other words, there's nothing down there. And every logarithm is supposed to have a base. Every logarithm really does have a base, really does have a number low down. That's what base means, right? Low down at the bottom of the G. Okay, well, what do you mean it's not there? Right. Well, what that means, so there's two kinds of logs. Let me write it over here. There's two log invisible bases. There's two log invisible bases. Let me write that a little neater there. So the first one, number one, if they just write log and they don't show anything like log of x equals y, that means log base 10. It's kind of weird, huh? We have an invisible 10. Yeah, so if they don't put any number down by the G, it means there's an invisible 10 there. So, now I'll tell you about the other one later. There's a second case. We'll get to that later. So right here I've got to fill in that 10. Why did I fill in the 10? It's invisibly there. So if the word log is written and there's no base showing, it's an invisible 10. It's called the common log. Anyway, okay, so what? So, well, now I'm going to change forms, right? They want me to write it in exponential form. How do you do it? Well, step one, the base stays the base, then the other two switch. So the 10, that's the base, and then the other two switch position. What do you mean they switch? Well, it was 10 to the s, now it's 10 to the n, and the s goes over there, and there's the answer. So you see the 10 came in there invisibly, because if there's no base showing, it's an invisible 10. All right, let's try number 3 here. Now we're going to go the other way. So they're giving me something in exponential form. That's an exponential. It doesn't have the word log, does it? It's a power. 7 to the q power equals m. And they want me to write it in log form. They want me to change it to log form. So I'm going to bring in the word log. Now, how do you do it? How do you change between the forms? The base stays, remember the two steps. Number one, let's write it. The base stays the base, and the other two switch. So the base is the 7, right? That's the base. Because how do you know that's the base? Because it has something on it. It has a q power on it. So that base will stay 7. The other two will switch, so the q and the m will switch. Instead of 7 to the q, it'll become 7 to the m. Right? The m. See how the 7 is lowered down? Remember, with a log, we always have a base number that is kind of below the line. It's at the bottom of the G, and everything else is on the line. See, the m is just on the line, and then the q goes over here. It is just on the line. You can see the answer right there. The 7 is lowered down because he's the base. The base means the bottom. All right, let's try this next one. Same thing here, right? That's exponential. We're gonna change it. Didn't spell that right. Exponential. Let's change to log. So I'm going to bring in the word log. There's no word log here. And the base stays the base, right? Base stays, so the 10, that's the base, right? It's got something on him. And then the other two, these two, they're going to switch, aren't they? So instead of 10 to the r, it's going to be 10 to the a, and the r goes over there, right? They switch. It's an inverse function. There's a switching. of inputs and outputs. Okay, but one more step. Now remember, base 10, that's the invisible, I'm not spelling that right. That's the invisible 10 base. So you don't actually show it. You just write log A equals R, like that. And that's the answer. You can put parentheses around the A, probably a good idea. And I probably should have done that up here too, parentheses on those M, on that M. So log A R, no base showing, because the base is when you show no base, it's invisibly understood to be 10. Okay, number 5. So now they want me to actually figure out an answer here. Okay, we'll start over here with log base 8 of W is 7. Now, we don't naturally speak log, right? So I'm going to step 1, change to exponential. That's why we spent time practicing how to do that. We're going to change this to exponential form. How do you change it to exponential form? Well, the base stays the base, and the other two switch. Instead of 8 to the W, it's 8 to the 7, and the W goes over there. See how the base stays the base, right? Base stays the base. The other two switch. Okay, great. Now, solve the equation. What do I mean solve? Well, take your calculator and take 8 to the 7th power, and you will get that. And that's our answer. That's what W equals, 8 to the 7th power. That big old number, what is it, 2,097,152. There we go. All right, let's go on to number 6 here. So they want me to solve this, another log question. So you know what to do, right? We got to step 1, change to exponential. Change it. So that means what? The base stays the base, the 4, that's the lowered down number. The other two switch. Instead of 4 to the Q, it's 4 to the negative 8, and the Q goes over there, right? Base stays, other two switch. Okay, now we've got to give that as an answer. Now remember what we learned about negative powers? Negative powers, they're unhappy. They're unhappy. They're negative. They jump to the other side. They're negative, unhappy where they're at, so they want to jump to the other side of the fraction. They want to jump to the other side of the fraction. So this negative power thing's going to jump down, and then it becomes positive. Then it becomes positive. It's happy. So negative powers are unhappy where they're at. They want to jump to the other side of the fraction, and then they become positive or happy. So that's how you remember negative powers. So it's 1 over 4 to the 8th. So there we go. All right, number 7. Solve this log for x. So here's our question. You know what we do. Step 1. Change to exponential. Change to exponential, which means what? The base stays the base. The other two switch. So the x down there will stay the base. The other two will switch. Instead of x to the 9, it's x to the 2, and the 9 goes over there. All right? And now on step 2, we solve. By the way, see how we got rid of the log word? There's no more log, right? You get rid of the log word, and when you do, the base stays the base, the other two switch. That changes it to exponential. You lose the log word. When you lose the log word, the base stays the base, the other two switch. Now, how do you solve for x here? Well, you know what to do. You square root it, huh? Square root of 9, because rooting cancels squaring. Square root of 9 is 3. The answer is 3. There we go. Let's try number 8. So, on number 8 here, let me bring it over here. Log base 6 of 1 over, well, it's okay, 1296. They want me to find out what that equals. Well, what we can do is we can say let's bring in let's just go equals x. You know, they don't have any right side, so I'm just going to call the right side x. That's the answer we're trying to find. Just call this x. Whatever it equals, it's x. Now, you know what to do. Step 1, cross out the log, change to exponential form, right? So when you cross out the log, what happens? The base stays the base, and the other two switch. This is the base. This is the low down part. And the other two, meaning the x and the big old fraction, switch. Instead of 6 to the fraction, it's 6 to the x power, and the fraction goes over there. Do you see what happened there? Now, step 2, we need to solve that. Well, how do you solve that for x? Well, that's kind of tricky. Here's what I would do. We're trying to find what power can we put up there. 6 to what power is going to make that fraction? Well, just take your calculator and try like 6 to the second power, and you'll get 36. And then try 6 to the third power. I don't know what you'll get. I'm going to try it right now too. 216. And so it's not working. Now try 6 to the fourth power, and you'll get 1296. Oh, that's it. That's my number. Yeah, that's your number, except you need 1 over 1296. What's going to make it jump to the bottom? -4, huh? Remember, negative powers make the answer jump down to the bottom. 6 to the positive 4, or regular 4, is 1296, but to the -4 power, that jumps it to the bottom, becomes 1 over 1296. Remember, negative powers jump to the other side. So that x is -4. Right there, that x, the power that needs to be on the 6, is -4. There we go. Okay, let's try number 9 here. So, find the logarithm. So, remember what we do again. Let me bring it over here. This will be easy once we remember what we're doing. Okay, so when there's no right side, you know, step 1, we put an x over there. Just stick an x on the right side since they're not giving us any right side. And then step 2, remove the log, and right, the base, when you remove the log, base stays the base. The other two switch. So remove the log, and the base. Now who's the base? He's the base. The base stays the base. The other two switch. So these two are going to switch, right? This whole thing and the x. So it becomes 3 to the x is 3 to the 1/5, doesn't it? Let me write that a little bit better. Right? The base stays the base. The other two switch. And now, step 3, solve it. Solve for x. What does x have to be to make those equal? It's pretty obvious. X has to be 1/5, huh? X has to be 1/5. Do you see that? So step 1, we put an x on the other side. Step 2, we remove the log, base stays the base, other two switch, and then we just solve for x. Let's try that on number 10. So down here on number 10, we have got, So step 1, log of, it's a million, isn't it? Okay, so you know what we're going to do on step 1? We're going to go equals x, right? Okay, and then on step number 2, cross out the log, base stays the base, the other two switch. The base stays the base, the other two switch. Now, wait a minute, I don't see a base. Right? Base is supposed to be at the bottom of the G word. I don't see any base there. There's no base. Right. So what is the base when it's invisible? What did we say back here? It was further back. There it is. Invisible 10 base. Right? Invisible 10. So I'm going to put in a 10 right there. It's really there. All right, let's do it. Cross out the log word. Base stays the base. The 10, which was invisible, now is visible, stays the base. The other two, meaning the million and the x, switch positions. Instead of 10 to the million, it's 10 to the x. When you lose the log word, it becomes the base stays the base, the other two switch. 10 to the x equals a million. Let me write that a little bit better. 10 to the x equals a million. Okay, now step 3 is you solve. Now that you got rid of the log word, right? That's what we do. So step 1, we put an x on the right side. Step 2, we cross out the log. Base stays the base, other two switch. We change to exponential form. Then step 3, we need to solve for x. How am I going to solve that for x? 10 to what power is going to be a million? Well, remember how powers work? Like, what's 10 to the second power? Let me write this a little better. What is 10 to the second power? It means 10 times 10, it's 100, 2 zeros. What's 10 to the third power? 10 times 10 times 10, it's 1,000, 3 zeros. So notice the power tells you how many zeros, doesn't it? Because it's just multiplying by 10 that many times, and every time you multiply 10, it just adds a 0 at the back. You know, like 10 to the fourth power is going to be, it's going to be 4 zeros. So what is that? 10,000. Anyway, so what? Well, how many zeros do we have here? 6 zeros. So what must this x be? X must be 6. So the answer is 6. There it is. All right. Good. Let's try number 11. Same kind of thing. Step 1. We have log of 1 over 100,000. And so what do we always do on step 1? Equals x, don't we? Step 2. Lose the log. Cancel out the log. And when you do, the base stays the base. The other two switch. So when you cross out the log word, the base stays the base, and the other two switch. So I'm going to come up here and I'm going to... and what's the base? I don't see any base here. So what does that mean? The base must be. It's an invisible 10. Remember, every log has a base at the bottom of the G, and if it's not showing, it's an invisible 10. All right, back to it. Cross out the log word. The base stays the base. The other two switch. Instead of 10 to that weird fraction, it's 10 to the x, and the fraction goes over there. All right? Step 3, solve. So how do you, solve for x? How do you find x there? Well, look, we just talked about 10 times 10. Every time you multiply by 10, it adds a 0. We have 5 zeros. So that's got to be 10 to the fifth. But it's on the bottom of a fraction. How do you get to the bottom of a fraction? What makes you jump to the bottom? When you're unhappy. -5. X must be -5 because the negative power, a negative in the power zone, makes it unhappy. It's like being negative at your job. It's unhappy at its job. It jumps to the other side, jumps to the bottom. So the answer is -5, as they said. Good. All right. Number 12. Okay, so how do we do this number 12? So first off, I got to show you. Remember earlier I showed you two. Let me change the color here. Two invisible log bases, right? Number one, if they just write something like log of x equals y, that means, it really means log base 10 of x, right? It's an invisible 10. Okay, well there's another invisible one, and that is if they write ln of x equals. Now ln, what this stands for, it's natural log. It's just kind of backwards. It's because it's French, really. It comes from some French word, logarithmic natural. So it's natural, it's NL, it's natural log backwards. And what it means, most importantly, what it means is log base e of x equals y. Now, so really it means there's an invisible e there. Now, what is, you might think, E? What do you mean? What's the letter E? E is a special number. You remember, like, pi is a special number, 3.14, blah, 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 blah. It goes on and on. Well, E's kind of like that. E's a special number. Let me go back here. E is 2.718, blah, 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 blah. It's a special number that math and science people use. Like pi is a special number, you know, pi is 3.14, and it also goes on and on and on. So E is a special number, and so when they write ln, they mean log base that special number, E. It's a special number. We call it by a letter E, and it's a special number. So there's two invisible log bases. If they just write the normal word log, that means the base is really 10. It's invisibly 10. If they write ln instead of the word log, ln, that's still a logarithm. It's natural log backwards, and it means the base is e. Okay, so what? Well, coming over here now, let me show you. On this one, there's really an invisible little e down there. You might think, yeah, but there's an e right there. No, this e is on the level, isn't he? He's not lowered down. Remember, the base numbers are always lowered down. They're at the bottom of the G. So like this one over here is at the bottom of the G. This 10 right here is at the bottom of the G. So there's another invisible, there's two e's there really. There's a lower down invisible e, and then the e they gave. Okay, so what? Well, basically what that means, I don't even need to show you that. I could just do this. These cancel. Remember what so the answer is just 1. Remember what logarithms are. The main point of this question number 12 here is to help you remember that logarithms and exponentials, powers, are opposites. They're inverses of each other. And so they cancel each other out. You know, kind of like a poison and an antidote. If you swallow a poison, you better swallow the antidote real quick, and it neutralizes it in your stomach. They're opposites. It's kind of like square root and squared, right? You know, like if you have the square root of x squared, they just cancel, and it's just regular x, isn't it? Why? Because a root and a square are opposites. So, you know, if you have, say, like the root of, 7 squared. Well, they cancel, it's just 7. You can tell because it's the root of 49, which indeed is 7, huh? See how the root and the square just cancel because they're opposites? That's the deal. A root and a square are opposites, and log and powers are opposites. They're inverse functions of each other. So logs, and I'm not writing that very neatly, and exponents, powers, are inverses. They cancel each other. They're the opposites. So the ln and the e just cancel out. Now, you might say, well, what if it was log E1? Yeah, that would not cancel out, because what would be the base in that case? Log has an invisible 10. 10 is not the opposite. So log base 10 of 10 to the 1, that would be 1. They would cancel out in that case. So as long as the base and the argument, what comes right after the base, are the same, they cancel each other out. So in this case, there really is an invisible e there, which means these guys cancel each other out. The ln is the opposite of the e. How about on this one? Same thing here, e and ln. So yes, so let me be really clear. E and ln are opposites of each other. So they cancel out, and the answer is just 5. Here again, e and ln. These are easy problems, right? You want a lot of these in the test, right? One more. This one's a little more tricky. How are we going to do this one? Well, the first thing you got to do is you've got to rewrite. We're going to cancel in a minute, but you first have to rewrite this. Do you realize that's e to the minus 4? Remember, negative powers flip it. They're unhappy. They're negative. And they flip it to the bottom of the fraction. Okay, so what? Why did we do that? Well, now that we brought that e up to the level, we can just cancel each other out, because remember, e and ln are opposites. So they cancel each other out, and the answer is negative 4. See, if we tried to cancel back here, it would have been wrong. The answer is not 1/4 or 4, right? You first have to rewrite it so that e is on the level, right next to the ln. Then you can cancel them out, right? They got to be right next to each other, right next to each other, right next to each other. Then you can cancel them out. So the answer is negative 4. All right, now this one, they just want you to use your calculator. Just literally take your calculator, put in log of 550 on the calculator, and you will get that answer. And they want at least 3 decimal places when you do it. Just hit the buttons on your calculator. And you'll find the log button just right there on your calculator. All right, let's try number 14. And so what are they doing here? Part A. 4 to the 5th is 1,024. They want me to rewrite it. It's equivalent to a log statement. Well, let's do it. So 4 to the 5th is 1,024. So now rewrite as a log. What happens when you rewrite something as a log? You remember. The base stays the base. The other two switch. The base stays the base, the other two switch. So when I bring in the log word that wasn't there before, the base stays the base, which means low down, the bottom of the G. The other two, these guys, switch. Instead of 4 to the 5, it's 4 to the 1,024, and the 5 goes over there. So there we go. Now they're saying they want me to write it in this form, so let me bring it down here. They're saying they want it log base 4 of A equals B. So the A is the 1,024, and the B is the 5. So it was just practice rewriting from an exponential form to a log form. Here it is again. Same kind of thing. They're giving me this. They want me to rewrite it. So 10, let me separate this, 10 to the minus 2 is 0.01. So you know what to do, right? When we rewrite, we put in the log word, and the base stays the base. The other two switch. So who's the base? The 10. The other two, meaning these two, switch. It's an inverse function. They invert. So instead of 10 to the minus 2, it's 10 to the 0.01, and the minus 2 goes on the other side. And the 10 is still the base. He's at the bottom of the G. So there it is, and they say, oh, we want you to rewrite that as this, as log base 10 of C equals D. So the C is the point 0.01. The D is the -2. There we go. Okay, let's try number 15 here. Same kind of thing. They want me to rewrite this expression. So how do you write it? You bring in the log word, and the base stays the base. The 2 stays as the base. The other 2 switch. Instead of 2 to the 3, it's 2 to the 8, and the 3 goes over there. So there it is. That's the answer they got. You can put parentheses on the 8 if you want. It's not. I don't think they'll require it. It means the same thing either way. And so now, coming on down to this one, same kind of thing. We have this expression. The base. So when you change to log form, the base stays the base. The other 2 switch. So instead of 10 to the negative, so the base will stay down there in the bottom. The 10 is the base. 10 is the base here. It's at the bottom of the G. The other 2 switch. Instead of 10 to the -4, it's 10 to the 0 point, what was that, 3 zeros and a 1 equals, and the -4 goes over there. All right. And so there we go. Oh, and you don't even need that 10, do you? Because remember, those 10s are invisible. So you can just write 0.0001. Just like that, no 10 needed, because when you write the plain log word, it's got an invisible understood base 10, which you don't need to show. Okay, number 16. Same kind of thing. Express the equation in a logarithmic form. All right, e to the x equals 5. So we're going to take e to the x equals 5. And when you rewrite, you know what? I'm going to bring in the word log, and you know what happens, right? The base stays the base. Who's the base? The e. He stays low down. And the other 2, they switch, don't they? Instead of e to the x, it's e to the 5, and the x goes over there. Write that a little neater, a little more neatly. There we go. Good so far. Now, what does it mean to have log base e? Let's go back over here. Back. Is it here? Yeah. So maybe it's one more over. Nope. That's right. There. 2 invisible logs. 2 invisible logs. Remember, log base e is the same as natural log. Log base 10 we just write as a normal log. See the difference there? Log base 10 we just write as the normal log word, and with the base invisible, the 10's invisible. Log base e, we also make it invisible, but it's the special word, logarithmic natural, natural log spelled backwards, with the invisible e base. So log base e, natural log, no e showing. So this becomes natural log 5 equals x. You just rewrite that log base e as natural log of 5 equals x. And they said, okay, yeah, we want you to rewrite it as this. So bring that down to match them up. ln of a equals b. So what's a? 5. What's b? X. There we go. On that one. So that matches up. Now let's try part B here. So on this one, on part B, they're saying, okay, e to the second power is x. So e to the second power is x. You know the deal. When we bring in the log word or lose the log word, the base stays the base. The other 2, meaning these 2, switch. Instead of e to the 2, it's e to the x, and the 2 goes over there. Okay? And then what is log base e? What have we learned? You can rewrite that as, that's ln, isn't it? Log base e is the special number. It's the natural log of x equals a. So I'll bring that over here. Natural log of x equals 2, I mean. And they want me to take this, bring it over here. ln of c equals d. So the c is the x, and the d is the 2. We matched them up. There we go. So whenever we rewrite a log, where we lose the log word or gain the log word. The base stays the base, the other two switch. And then log base e is natural log with no base showing. The invisible understood base is e. Okay, so number 17, they want me to rewrite this as a log equation. Okay, as a log equation. How are we going to do that? Well, you know the deal, right? When you bring in the log word, the base stays the base, low down. The other two switch. Instead of 2 to the 4, it's 2 to the 16. 4 goes over there. There we go. And this one, now what about this one right here? This log, I don't see a base. Remember, every log has to have a low down number next to that G. I don't see any base number, any low down number next to that G. So what's really there? 10, huh? There's really a 10 there. Right? The normal log, you might think, well, how do you know if it's E or 10? Only if they write L in is it E. Right? If they write the normal log word, L-O-G, and then it's invisible 10. If they write L in, the natural log, that's the one that has the E. That's the special number. We call it the natural log because it occurs in nature. It's kind of a long story. You'll learn more if you take calculus about why that E number is a naturally occurring number. Anyway, let's get back to it. So now, on this case, we're going to lose the log word. Right? They want me to rewrite it as an exponential, meaning not a log. The last problem, we started no log and we rewrote it as a log. This time it's reverse. We're starting with a log and then getting rid of it and writing it as an exponential. Well, what happens when you cross out the log, get rid of the log? Well, you know, either way, base stays the base, other two switch. So who's the base? 10. He continues to be the base. And the other two switch. Instead of 10 to the 0.01, it's 10 to the minus 2, and the 0.01 goes over there. They switch. That's the answer they say. All right, number 18, same kind of thing again. Rewrite this as a log. So I'm going to bring in the word log, and when you do, the base stays the base, that's that 4. The other two switch, these two will switch. So instead of 4 to the 4, it's 4 to the 256, and the other 4 goes over there. All right, and now the last one. This one, now there's an understood 10 there again, right? When you write the normal log word without a base showing, it's understood to be 10. We're going to write it as an exponential, meaning no log. So cross off the log. When you lose the log, or like on the last problem, we gained the log word that wasn't there. When you lose the log or gain the log, what happens? Base stays the base. Other two switch. So this base of 10 is the base, and then these two will switch. It's an inverse function. Instead of 10 to the 0.001, it's 10 to the minus 3 equals 0.001. Same statement made in two different languages. There we go.